Hello everyone. This is Jessil Precious, Jessily Polymath with you. Um, it's been a beautiful delight so far. Um, why are we here? Well, I wouldn't know, but I couldn't possibly be here without a justified reason. So, firstly, there's this question that I'd love us for us to solve. Um, let's see what that would be. Okay, so I'm looking at the number two of that particular question. If log b plus 2 of base 8 plus log a of base 8 is equal to x minus 1 over 3 as an equation 1, then log p minus 2 of base 2 minus log a of base 2 is equal to 2x plus 1 as equation 2. Alright, maybe we should expand this a bit so that we would know what we're looking at. Okay, so this is a question. And then they're asking us to show that p squared is equal to 4 plus 3 plus 32 raised to the power of x. If x is equal to 1, find the value of p. Okay, so I'm going to find a possible way to make this as short and succinct as possible. So I'm going to take you to the board and then we try to replicate it. So yeah, why not? Okay. Firstly, let's try replicating the question. So, okay, so we have log base 8 of p plus 2, then let's say plus log base 8 of a is equal to, oh, let me check the question again, sorry. Okay, okay. That's x minus 1 over 3. And then that was equation 1. Then equation 2 said log then we have okay, and we are asked to prove that p squared is equal to 4 plus 32 to the power of x. All right, let's see how that goes. I'm going to start from here. Solution. First thing I'll do, I'll try to recognize the laws of logarithm. One most popular we know is that if we had a log of a certain base a to a number b, and then plus log of that same base a to a number c, it is the same thing as saying log of that base b times c. And if we also had something like log of base a to a number b minus log of that same base a to a number c, it's equal to log of that base uniformly having b as the denominator divided by c, as in having b as the numerator and c divided as the denominator. Okay, so and then generally the law of log, if we have a certain base a to a number b equaling c, it is the same thing as saying a raised to the power of c equal to b. So if A was raised to the power of C, it would return us to B. So nonetheless, let us dive right in and show how it relates to this. So checking the first equation, we have log of base 8, but then to a number p plus 2, and then adding log of that same base to a number a. So we're going to apply the same laws. Let me call this one equation 1. I'm going to apply equation 1 on the first equation, law 1, sorry. Oh, hmm, all right. This will take a little time. So it should be law 1. So as the case may be, we could have I'm going to apply law 1 in the equation 1. So that would mean, therefore, I would want to conserve my space. So we have here log base 8 of p plus 2 multiplied by a. That's what law 1 was trying to explain. And then is equal to x minus 1 over 3. So I'm going to apply law 2 in equation 2. So, oh, sorry. I'm going to apply apply law 2 in equation 2. All right. So we have here, remember, this is still our equation 1, just that we've defined it based on law 1. And then we have equation 2, and we are redefining it based on law 2. So we have here, so this is still our equation 2. So the next thing we're going to do is we are going to multiply equation 2 by equation 1, or not that, we're going to break it down further. We're going to apply law 3 in both equations. Applying law 3 in both equations. So applying law 3 in both equations. So if we were to apply law 3 in both equations, that would mean for equation 1, we're going to have 8 raised to the power of, all in the bracket, x minus 1 over 3, bracket close, is equal to alright, so we have, alright, for equation 2, so we have 2 raised to the power of 2x right. Oh, sorry, my writing isn't just in place. So we're going to have this, sorry, that would be 2x plus 1, all in the bracket, because they are all power to 2, is equal to b minus 2 over a. So this is our equation 2. So the next thing we're going to do is multiply both equations. Multiply both equations. Multiply both equations. by each other. So if I were to multiply both equations by each other, that means for the left hand side, we would be having 8 raised to the power of x minus 1 over 3 times 2 raised to the power of 2x plus 1 is equal to, we have here, p plus 2 times a, then times p minus 2 over a. So checking it out, a is going to cancel out a, and then we have here p plus 2 all in a bracket, p minus 2, and then I'm going to convert 8 into to have a base of 2. We are going to convert 8 as an index notation to have a base of 2. And we all recognize that 8 raised to the power of 8 is the same thing as 2 raised to the power of 3. So applying that, I'm going to say 2 raised to the power of 3 all in a bracket, x minus 1 over 3 all in a bracket, then times 2 raised to the power of 2x plus 1 all in a bracket. So at this point, we're going to say on the right hand side of the equation, and then on the right hand side of the equation, we have difference of two squares, which literally means p squared minus 2 raised to the power of 2. That is difference of two squares. Once you expand this bracket, you will get the difference of two squares. So at this point, we're going to now have, for the left hand side, 3 multiplying power of x. So we have here 2 raised to power 3x, and then 3 multiplying 1 over 3 would give me minus 1, and then we have times 2 raised to the power of 2x plus 1. So remember, for those who didn't understand what we did for the base 2 to the power of 3, and then look at what happened. We said 3 all in a bracket, x minus 1 over 3. So 3 times x would give me 3x, and then 3 times 1 over 3, just like we have it, 3 gets to cancel 3, leaving us with just negative 1. So that's what we did for this side. So the next thing we're going to do is we're going to follow up the law of indices, which says that when index notation of the same base are multiplying, the powers are to be added. So I have here equal to 2 raised to the power of 3x minus 1, minus 1 plus 2 raised to 2x plus 1 is equal to p squared minus 4. So let us simplify this. If we are to collect like term for the powers, collecting like term for the powers, that means you're going to have, let me just take this part off the board. We are going to have 3x plus 2x, and then minus 1 plus 1, which is equal to 5x, and then we have 0 for these two numbers. It's going to be 0. So we have here 5x. That means you are going to have, when the powers are simplified, look at the powers for those who don't know. So we are going to have 2 now raised to the power of 5x is equal to p raised to the power of 2 minus 4. So 2 raised to the power 5, as the case may be, 2 to the power of 5 is the same thing as 32. So we're going to have 32 to the power of x now, and then 32 to the power of x is equal to p squared minus 4. Alright, as the case may be, this is already looking like what we are asked to solve. Let me clean up the board a bit. Okay, this will take a little while, but trust the process. So if I were to make oh god, this is a long process, but it's all for the fun. Okay. Yeah, in case you didn't know, I'm kind of hosting online classes for students who are willing to sit for, who are ready to sit for external exams. I could help you with math, physics, and further mathematics. So let's conclude up. So we have here, if I were to make p squared subject of formula in that equation, we are going to have here p squared. We're going to have here p squared is equal to 32x to the power of x plus 4, which also, by proper rearrangement, we also have 4 plus 32 to the power of x. So if I were to find what p would be when x is equal to 1, we are going to have here p squared would be equal to 4 plus 32 to the power of 1. 32 to the power of 1 will still give me 32. So we have 4 plus 32 equal to p squared. So p would be equal to square root of p squared equal to square root of 36. P squared gets to cancel, p gets to cancel, the square root gets to cancel square, and then we have just p, and then the square root of 36 is 6. What we did here was square rooting both sides. So I think this is it. Don't forget to follow and subscribe to my YouTube channel. Follow us up on Facebook too. It's all for the fun. Please. So this is it. And then look at our group here, Jessily Polymath. Provided you want to join us, please. All right. Okay, sorry.